So we're going to resume with lesson 11. We've written a really simple unit test, but it's kind of a crappy test. So how could we improve this? What should we be checking that would be a little more specific to the outcome we're expecting, right? So we're calling our index method here that returns a view, and our test passes, but all we're really checking is that we get something back. If we wanted to more accurately test this, what should we be checking for instead? We'll want to maybe rewrite this assert somehow. And I think we maybe mentioned it before we took the break, David, about what the method is actually supposed to do. So the result that we expect is what? Well, what we are expecting is that our index view is going to load. So our unit test should actually be checking for that instead. So I'm going to rewrite my assert. We're not just checking that we get something back. We're going to assert. Yeah, we want to assert. So we are expecting to get a string called index, and that this should match the name of the view that gets returned. Now, this is a more accurate. It's not just that we're getting something back, we're getting specifically a view called index. Now, when I rewrite the assert this way, we now get a bit of a type mismatch error. And notice when I hit result dot, view name is not one of the options that are available to me. And this has to do with the return type in our controller methods. And so it tells us that IActionResult doesn't contain a definition for view name. So what, our method, it returns an IActionResult class. So IActionResult, this is an interface. It's like a parent class. So a view is one child, it's one kind of IActionResult, but we might get other IActionResults, like we see here, for example, are not found. This is just a status code. It's not actually a view result. So in order for us to evaluate the name of the view, we need to have to cast. We've got to change the data type of what comes out. So what I'm going to do is in front of this, I'm going to add this view result casting, which does fix my error in my assert. And it gives me an error here. So we've solved one problem. This is the nature of unit testing. We solve one problem, we create another one. So I'll put in a comment. We will cast the IActionResult class return from the method to its child class of view result. And when we mouse over, we get namespace could not be found. Our unit test doesn't know what a view result is. So we need to supply a reference to .NET Core MVC. When we add that reference, controller goes, oh, okay, now I know what a view result is. Okay, so we're going to call index, which will give us back this parent class of IActionResult. We're then going to cast that, modify the data type as a view result, and now we can actually inspect the name. So now I want to run my test again. Now I could run it straight from here. I could go back to Test Explorer as well. Either one will work. So if I just click my little green checkbox. If I have it here, I can click run. If you don't have this checkbox, Tushar, I don't know if yours showed up yet or not. If you don't see it, you can just go to Test Explorer and you can run your test again from here as well. Doesn't matter. I'm going to run my test. Make sure we get the index view back. And now we get a red X. So our modified test executed, our code compiled, it looks good. So if I want to know why the test failed, it shows me the error message here. We expected a string called index, but we actually got back a null. Well, that's kind of weird. Why did we get back a null? When we run it in the browser, it's fine. We call dummies and it loads the index view. So that's kind of odd. Now this is a case where the unit tests are going to help us, another case where the unit test is going to help us write better code. So even though this works at the browser, for some reason, it doesn't work when we test it. And I'm going to show you why. I'll just put in a little breakpoint here, and I can debug my test. So I'll right-click my test name. You don't have to do this with yours, but you can try it if you want. I'm going to click debug. So it's going to run the test again, but we can watch it execute one line at a time. So our result initializes to null. I'll click F11 to go to the next line. So it calls our method. It returns a view. So now my result, I've got a view result here. And if I just put my mouse over and expand, all these fields, including the view name, are actually null. So then when I do my assert, where we're checking that the view name is a string that's equal to index, the test fails, right? It tells me that the view name is null, which is not what we expect. We would have thought, you probably would have thought this test should pass. So if we go and look at our controller, why do you think it fails? Why, when it returns the view, why is the name null? And how could we fix that? This one I'm going to actually wait to get an answer in the chat. How come that view name property shows as null, and what would we do to correct it? Feel free to take a guess. We are going to need to change something in our index method. Chris, you're close. We'll work with the view data next in a minute. Good guess. It's not actually the view data, but we will. I'm glad you mentioned that because we're going to come back to that next. So what could we do here to ensure that the view we're returning is explicitly named? Yeah, we can, thanks Tushar, we can explicitly, in that return view, we actually want to name it. Okay. Actually, the other way around, Chris, you had the right idea. We're going to put index. We're going to explicitly provide the name. I think that's what you were getting at, which is what Tushar was suggesting. So I'm going to run it again. I'll put my debugger on again. I'll try the test one more time. Oh, it's actually still running. Oops. Let me run it again now. So now when we run it, let's see what happens. Now notice the test passes. So what the unit test is telling us, and now our green checkbox appears again. So wherever we've got return view statements, we should be more intentional to make sure the correct view gets loaded. So going back to your assignment, this is one of the hints I mentioned. Wherever you've got a return view statement, you should be doing what we just did in our index, providing the name as a string parameter. So that way we are verifying that not only are we getting a view back, but we're getting the view we expect. If we call index, we don't want to get the details view. We want to get the index view. Okay, we're going to write one more test here, and then we're going to leave the dummies test alone. Chris, let's work with the view data. So then we can actually write another test here. So we'll say view data message. We'll set up a variable. The view data is pretty similar to the view bag, just an object we can pass from the controller to the view. We put a string in here. So we'll set this up. We'll display this message on the index view. So I can output our view data message in like a paragraph tag. And then we can write a unit test to verify that our index method displays the correct message variable. Here. Just put on a paragraph tag. So we're just going to output it to the screen. Okay, so now we've got both our H1 as well as our message variable that we are setting in the controller, passing to the view using our view data object. Again, here's the line of code here. So we want to go back to our unit test class, and we're going to write a separate unit test to check that the view data message is what we expect it to be. Okay, so we've got two different things happening in our method, so we should write two unit tests. Now, some developers will write multiple assert statements in the same unit test, which we could do. We could actually first check this, and then check this in the unit test we already have. So if we wanted to, we could also, I don't recommend this, we'll talk about why. I could also say, assert our equal result dot view data message, and then whatever the string we expect here. I could do this, so I could first check we got the right page, then I could check we've got the right view data. I don't think this is a very good idea, and I don't recommend it. What's the problem with having multiple assert statements in the same test? Some developers like this because they think it's more efficient, but I don't think it's very good for quality control. How come? I'm going to wind up removing that line in blue. What's the problem with taking this approach where we're testing multiple conditions in one test? Why would we be better off to have two separate tests? Okay, yes. Yeah, David, that's true, Chris, but yeah, David, that's the problem. If the test fails, I don't necessarily know why. Did this part of it fail? Did that part of it fail? Did they both fail? So it's not really a good guide to helping me debug the code and rewrite the logic. if we have multiple asserts. So, school of thought is sort of divided on this. I am firmly in the camp of one assert statement per unit test. So we can test each outcome in isolation from the others. So we'll write another test here. So I'll give it this test method. Void, and I'll say index shows correct message. Now our arrange and act, they're exactly the same, right? We're setting up the same object. We're calling the same method. So I can just copy and paste. It's only the assert is different. So again, some developers hate that duplication, but I think it's necessary in order to get the best results out of your unit test. So now we can assert. So we're checking for the string. We put a string in here, so I'll just copy that. So this is what we are expecting, and we're comparing it to our result. View data. And then inside the view data, we're comparing it to the message variable. So these should be the same. We want to make sure our page is getting the right message from the controller. So this test shows as green. This test is new. It's never been executed, so it shows for me as blue. So I'm just going to run it from here. And it also passes. Unless these strings match exactly, if I do this and run it again, my test should fail. Which it now does. So we expected, we put a string in here with 3 X's, and we put a string in here. Put it back. It should pass. Okay, so these were pretty simple examples. We're going to leave this class alone, and we're going to want to start actually testing the index and details methods of our pets controller. So I'm going to create a new class inside my unit testing project to do that. So I got 2 of 2 working tests. There's also a useful tool if you have the enterprise version of Visual Studio. I will show it to you quickly. If you have the community edition, you don't get this feature. It's not required, it's just kind of useful. There's actually a few. One of them is called live unit testing, which you can enable. And what this does is as you write the unit tests, the compiler actually starts checking them and indicating whether they will likely work or not. So as I write the code in here, I'm going to get check marks in green or X's in red. So if I can just start my live unit testing. Again, this is just an optional feature. It's not required. So don't worry if you don't have it. It starts to tell me, yes, this will likely pass. The other tool here, and I think everybody should have this, is under test. We've got analyze code coverage for all tests. So I'll show you what this works, how this works. So it shows me a hierarchy of the whole project. And then if I open up, we can see in my Positive Pets web project, we've covered 5 blocks of code, which is 0.18 of 1%. So we have unit tests that cover 1/5 of 1%. And if I drill down and open my controllers, it tells me the dummies controller is actually fully covered by unit tests. There's no code that isn't tested. And here on the second button from the right, it says show code coverage coloring. If I turn that on, when I look in my controller, it now turns blue, the code inside our method, because we have unit tested all of this code. So I get that visual indicator as well as these numbers. If we look at the pets controller, notice everything inside is red, meaning no unit test is covering any of this. So these are not required tools. They're just kind of useful. They can be useful in helping us kind of go through the process of performing that quality assurance with unit testing. We'll maybe come back to this. So as we start to unit test our pets controller, if we keep rerunning this tool, right now, we're at 0% covered, but as we write the unit tests, we can come back and see our progress. Again, if you're on community and you don't have those tools, it's not a big deal. They're not required, they can be helpful. So I'm going to right-click my unit test project. I'm going to click Add, and this time I'm going to pick a class, which we will call Pets Controller Tests. So this is where the unit tests we're going to write this week, and then next week in your lab, they're going to go in the Pets Controller tests. And the very first thing we need to do here, and this is critical, is in order for your unit tests to be able to execute, your unit test class has to be declared as public, which by default, when we create the class, it doesn't have that public scope. Right? Notice our dummies test class, it's got public here. So we're going to need to add the public scope and then define it as a test class. So before the word class, I'm going to add in public, and then I'm also going to add this test class. Annotation, which is going to require us to reference the Visual Studio unit testing library. So when we create the project, Visual Studio automatically gives us this reference and this code in our first class, but we'll have to manually add it to this controller. So we'll try our first method here. So inside the class, again, we'll add a test method. And again, we'll call it maybe index loads, index view. So basically the same test we already ran in the dummies controller. Right, so in our dummies controller, we had an index method that returns the index view. In our pets controller, we've also got an index method. Now there's some other things happening here. We're running a query, but again, we're returning a view. In the browser, if I go to pets, I get an index view. So again, we will arrange, act, and assert. So again, we'll create a controller. Let's say new pets controller. So just like in our other class, we created an instance of our dummies controller. Here we want to create an instance of our pets controller. We will need to reference the controller's namespace here, just like we did in our. So we've made this reference. Now this is going to get a little more complex. The same code we had in our dummies controller test, I'll just go back here. Right, this code worked. We referenced our controllers, and we created a new dummies controller this way. Yet when we try it here, we actually get an error. How come this behaves differently? Why did this work in our first unit test class, but it's failing for us now? What is this error telling us? There's no argument that corresponds to the required formal parameter context. of the pets controller. Thank you, Colton. We need a context for the database, right? Let's go and look. We'll go look at our two controllers and compare them. In the dummies controller, we could just create an instance of the class and call the methods, no problem. But in the pets controller, right, our pets controller, it has in the constructor, every time we instantiate our pets controller, there's a dependency here. You can't call the pets controller and not provide a database connection. So Colton is exactly right. So we need a database connection. Right? We can't call this as empty. It's saying you're missing that application DB context. Now we've got a problem here. We could connect to our database and pass the database connection. The problem is that would be integration testing, right? That would be testing our web application and our SQL server together, which we want to do, but that's not what we're doing today. We're doing unit testing. We want to test these methods in isolation, but where our web app is disconnected from SQL server. So this causes us a little bit of a challenge. So how do we test the database when we don't want to use the database? The answer to this is we are going to mock, we're going to disconnect from the database, and we're going to create a mock, like an in-memory database instead, kind of like HTML5 local storage. We're just going to create a database in memory for the purpose of unit testing, and we will provide that instead. So up at the class level, so a class level vars for use in all tests. So all of the tests are going to need a database. So rather than creating a database inside of every test, we'll create it once. So create private application. So we're going to need our application DB context. So we'll declare it here. And we will need to reference our data folder. So we'll add this reference. And then what we want to do before we can call the pets controller, we're going to need to initialize, create our in-memory database. And then we can pass our in-memory database to the controller. Now, we're going to need to do this for all our unit tests. So fortunately, MS Test gives us a special method called test initialize. And this method will run before all of our unit tests. So use this special startup method. That runs automatically before every test to do global arrange. Okay, so instead of needing to set up our database and create the controller in every test, we can do it in one method, and we'll give it this special test initialize. So it doesn't get test method, it gets test initialize. And we'll also call it test okay, so by putting test initialize above, it gets called automatically before every single method. So we're going to set up a new database, but it's an in-memory database. And we're going to provide a few options here. We're going to use an in-memory database. And every in-memory database, it needs a unique ID. So we can use the GUID class to generate a new ID each time. Now, again, we're going to need to make a reference here. We can't create this database without Entity Framework Core. So we fixed one error on line 23, and now it gives us another error. Because I don't know what in-memory database is, but this time there's not actually any code hints. There isn't a code way to fix this. The way to fix this is with a NuGet package. Right now, our project is not configured to use an in-memory database. However, there is a package. If I go to Tools and NuGet package, and we want to manage the NuGet packages for the solution, we'll go over to the Browse tab and just search all one word, search for in-memory. There are a number of different packages or frameworks we could use to kind of create a mock database. So we want this one, Entity Framework Core in memory. But we have to pay attention to a few of the options here. They're kind of important. Over here, wants to know, now we've got two different projects. We want to install it in the unit testing project. We don't need an in-memory database for the web project. We only need it for unit testing, so check here. I also think, we want to downgrade the version because the latest version 6 is for .NET 6.0. Our project, we're not using .NET 6.0. We're using 5. So I'm going to change to a version that starts with any version that's 5+. So check off the test project. Make sure your version number starts with a 5. And then I'll install it. There's another common package called mock, M-O-Q, that I've used in this course in the past. I think the in-memory database is a little easier to work with than mock, even though mock's probably a little more popular. We could actually check. So in-memory at 89 million downloads. Actually see. I'm not going to use mock. Yeah, mock's 238 million down. So more popular. It is the most popular. I've used it before, but I think it's a little more code intensive and a little more complicated. So now you'll notice now that clears up our error. So our in-memory database that was not recognized earlier, it's now recognized once we install the Entity Framework Core in-memory package. So we're setting up the options. So this would be set up and create in-memory DB. So now we can create a new database here with those options. So now we've got a database connection we can pass here. So there's our setup, and my live unit testing is now indicating, okay, everything should actually work so far. So we needed to install that package. You'll have to do this in assignment 4. We'll need to declare and create an in-memory database, and then we can pass it to the controller. So now our act in assert should be the same as it was in the dummies controller. Save our result equals controller.index. and our assert, we will expect a view called index, and we will compare it to our result view name. When we write the code this way, we get an error, same error we got before. So we are going to need to cast the result. That fixes our error in our assert. We'll need to add a reference to the MVC library, which I'll do. Now, this seemed to work in our dummies controller test. I'll just jump back for a second. We created the controller. We called the index method and cast the iAction result as a view result. And then we could check that the view name was equal to index. We've got virtually the same code here, although again, our controller is now getting a database object. So how come this fails? Cannot convert type system.threading.tasks.task of iAction result to a view result. So again, something's a little bit different in the index method of the dummies controller and the index compared to the index method of the pets controller. So here was our dummies controller. It returned an iAction result. In the pets controller, we've got iAction result, but it's wrapped in this async task. So what's the difference between these two? What does this async task do? We didn't have this in our dummies controller, but when we scaffold the products controller, the scaffold automatically uses async and task. What does async? What does that async keyword mean? Anybody have an idea? We don't have to dive too deep in the details, but we're going to have to deal with this. This async keyword means our method runs asynchronously, meaning it does not block any other code that's trying to execute on the same thread. So it's still returning an iAction result. It's just the way the method gets returned is slightly different. So that means in order for us, how we call it and retrieve what comes out also is going to be slightly different. So I'm going to add on here at the end, if I add dot result, this is the result of the task. So this will then give us our iAction result. Okay, well, it's suggesting this isn't going to work, but we're going to try it anyway. I'll run the test. And as the live unit testing predicts, it fails. Now, same error we got before. We expected index, but the name of the view that got returned is null. Sure, Colton, you mean you want to look at the return type? Okay, I didn't change anything here. So in the controller, in the dummies controller, it just returns a simple iAction result. The pets controller that we scaffolded It's scaffolding using asynchronous code. It's designed to be faster. So our iAction result, it's wrapped in this task first. So the way we call the methods is slightly different. This worked fine for the dummies controller, but it didn't work here without this. We had to add this dot result on the end. That can then parse out that iAction result, take it out of the task. So we needed to add this dot result property on the end here. So our code would compile. Yet the test still fails because it's expecting a string of index and it got a null. So now our solution is the same solution we had with our dummies index, where we returned the view. We want to be explicit about the name. So we're going to update our pets controller here. Right now it returns asynchronously with this await. It returns our data, but it never actually specifies the name of the view. So we're going to add in as our first parameter here a string of index. So I'm going to put this in. So we're going to return the view called index, and then we're going to pass it the data model so that we can see the list of pets. So if I save that change, notice my live unit testing now suggests, okay, this should fix the problem by adding in the view name here. And I can run it even right from here. And now my test passes. Our method returns a view name called index, which is exactly what our unit test is looking for. So we've tested this part of the view. I'll go and run my code coverage again. It's not perfect. It can be a little misleading, but we'll look and see what did this. We're up to, all right, 2.26%. So now when I look at the pets controller, it says index is 100% covered now. Right? So, sorry, the index method, it's blue. It isn't really though. We're checking we got the right view, but we also need to check the data model. When we call the index method, do we get a list of pets? And this is where we're going to also use that that in-memory database we've created. So we've created a database right now, but there isn't actually any data in it. It's empty. So what we're going to do when we come back is we're going to create some fake data and put it in our database. So then we can actually not only test that the correct view is loading, but we can check that that view contains the right data, which in this case should be a list of pets. So I'm going to upload what we've done so far to GitHub, and then we're going to need to do some more work here in our arrange to create a few fake records here, and then ensure when we call a method that the data we get is what we expect. So we'll write another test for index, and then we'll return to the details test that we talked about earlier. No ID, invalid ID, and valid ID. So we're going to do, I think, 5 more tests today inside of our pets controller. I'm going to upload to Git now. We will take a break, and we'll resume at 1 o'clock. First pet test. Okay, we'll come back in 10.